In the previous video, we were looking at the function y equals x squared that would create a parabola, and we looked at the effect of a, h, and k variables on that function to see how we could move it and how we could also make it wider or skinnier depending on what the numbers are. Well, in this video, it's going to be very similar. We're going to again be looking at the effects of a, h, and k, but instead we're going to be looking at three new functions: the square root function, the absolute value function, and finally the cubic function. So let's get it on. The first function we're going to be looking at is the square root function, and you can see it on the graph down here. I chose some values specifically for x. I chose 0 and then 1, 4, and 9. And the reason why I chose those values for x's is when you square root them, you get a nice whole number. I could have chosen other numbers like, for instance, 2, but if I had chosen 2, I'd have the square root of 2 over here, which is about 1.4, and I didn't want to deal with that decimal. But anyway, you can see the graph over here. You can see it starts at 0, 0, and the domain is x can be anything greater than or equal to 0. Same thing for the range, which makes sense because you can only square root positive numbers or 0, and when you do that, you're going to get a positive number or 0. So let's now take a look at how this will look with an equation that's more complicated. If you remember from the previous video, one of the things you want to do right off the bat is you want to find the a, the h, and the k values. So a is the value out in front here, and that's going to be 2. H is going to be, in this case here, remember, we're going to think of this as x minus, and in this case it'd be x minus a negative 3, because minus and minus would be plus. So h is actually negative 3, and k would be the number out in front here. And if we were thinking about an actual parabola, h comma k would be our vertex. Well, here there's no vertex because we're doing a square root, but we're going to call that the locator point. So that is going to be negative 3, negative 4, and that is going to be the beginning of our square root curve. So I'm going to go negative 3, backwards 3 to the left, and then down 4, 1, 2, 3, 4. So that is going to be my locator point, and my graph's going to be kind of coming out here. So that is going to be my first point, negative 3, negative 4. And if you remember, I chose certain numbers that I want to use. So I'm going to use negative 2 for x. So why would I want to do that? Well, it's actually pretty simple. If I were to plug in a negative 2 up here, I'm going to get negative 2 plus 3 would be a 1. The square root of 1 is 1. 2 times that 1 is 2, and then finally 2 minus 4 would give me negative 2. So that's why I chose that, as I want to get a nice whole number inside here. So that point is going to be here. I'm going to go left 2, down 2. Another one that would be really handy to have is if this was the square root of 4. So to do that, I'm going to choose the value of 1. 1 plus 3 would be 4. The square root of 4 is 2. 2 times that 2 would be 4, and 4 minus 4 is 0. So 1 comma 0 would be right over here. And then another one that would be really handy is that wouldn't it be nice if this was the square root of 9? So to make that happen, I'm going to use 6. So 6 plus 3 would be 9. The square root of 9 is 3. 2 times that 3 is 6, and 6 minus 4 would be 2. So I'm going to go out to 6 comma 2. So 1, 2, 3, 4, 5, 6, up to 2. And now my graph, my square root graph, is going to look something like this. And then finally, if I want to talk about domain and range, domain is about the x values. So x can be anything from negative 3 or higher. So I'm going to say x is greater than or equal to negative 3. Range is about my y. Well, the lowest it ever goes is down here at negative 4, and it can be anything greater than that. So I'm going to say y is greater than or equal to negative 4. So that's how a, h, and k works with square root graphs. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. The next type of graph is what we call the absolute value graph, and it's going to look a little similar to a parabola, but it's going to be a V-shaped graph here. We're going to have what looks like a vertex. I call it a locator point. But you can see if we plug in some values over here, for instance, the absolute value of -2 would be +2. So that's where this point comes from. And these are the other points over here too. The domain x can be anything. So we'd say -infinity is less than x is less than infinity. And then in this case, the range can only be 0 or higher. It would be impossible to have an absolute value be something negative in this case here. So how would this look when our graph is a little more complicated? Well, step one would be, let's find a, h, and k. So I'm going to go ahead and write those out right now. A would be the multiplier out in front, so that would be -1/2. Over here, remember that's x minus a +2. It's always in x minus form. So that means our h is actually a 2. And then our k would be the +3. So our locator point, which would be similar to a vertex, would be 2, 3. So I'm going to go ahead and find that. So here's my 2, 3 right over here. I'm going to put that in the middle of my table of points here. There will be symmetry like a parabola, so I'm going to go one higher and also one lower, and I should get the same value. Now if I choose a 1, 1 minus 2 will be -1, and then I'm going to end up multiplying by -1/2, and I'm going to get a number that's not whole. So I'm going to change this instead. And instead of using 1 and instead of using 3, I'm going to instead use 0 and 4, and you'll see why right now. If I plug in a 4, 4 minus 2 would be 2. The absolute value of that would be 2, and 2 times -1/2 would be -1, plus 3 would be a +2. So that ensures by putting in a 4 here, I'm going to get a nice whole number. Same thing with the 0, I'm going to get the same answer. So I'm going to go 0, 2 would be here, and then 4, 2 would be over here. I'm going to get a couple more points. I'm going to use a 6, and I'm also going to use a -2. Once again, I'm going to have symmetry, so whatever I get for 6 for the y value will be the same for x. So if I plug in a 6, 6 minus 2 is 4. Absolute value 4 is 4. 4 times -1/2 is -2. -2 plus 3 is a 1. So I'm going to go out here. I'm going to go ahead and put those there as well, and then I can go ahead and finish off my graph. So it should look about like this, and over here, same kind of thing. There we go. My domain. What can x be? Well, x can be anything. So I'm going to say from -infinity all the way through +infinity. Range. What's the highest and lowest my graph goes? Well, the highest it ever goes is this point here, which has a y value of 3, and it's going to continue to get lower. So I'm going to say y is going to be less than or equal to 3. Finally, let's take a look at the cubic graph, which would be y equals x to the third. You'll notice over here there's no symmetry like some of the other graphs we have here. And what you would do is just take the value of -2, multiply it by itself 3 times, which is -8, which would be this point down here. Domain, x can be anything, same thing. Range, y can be anything too, so it can be all real numbers. Let's go ahead now and see what happens when we change the values of a, h, and k. So let's go ahead and start with identifying what a, h, and k are. So a would be the multiplier number out in front, so that would be a -1. H in this case would be -2. Remember, it's x minus a -2, so that's why it's -2. And k would be the number at the end here, so it'd be a -1, which tells us our locator point is going to be -2, -1. And so I'm going to go ahead and find that. So -2, -1 would be right there. So remember, as we graph this here, that the basic graph of a cubic graph would look something like this. This is our parent graph. So there is no symmetry. So we're going to need to find all other 4 points. There won't be any matching on the y's here. So I'm going to go a little bit higher, -1, and see what happens here. If I plug in a -1, -1 plus 2 would be 1. 1 to the third power would be 1. 1 times -1 is -1, and -1 minus 1 is -2. So this would be -1, -2. I'm also going to plug in a -3. So -3 plus 2 would be -1. -1 to the third power would be -1. Times your -1 is 1, and 1 minus 1 is 0. So here is -3, 0. Let's plug in a 0. 0 plus 2 would be 2. 2 to the third power is 8. 8 times -1 is -8. Minus 1 is -9. So 0 Negative 9 would be down here. And then finally, our last one would be, let's use negative 4. Negative 4 plus 2 would give us a negative 2. Negative 2 to the third power is negative 8. Times this would give us 8, and 8 minus 1 is 7. So negative 4 comma 7 would be right about here. I'm going to change color here. I'm going to go ahead and connect them as best I can here. So here we go. Going to connect them right through there, and then it's going to come back down this way through that point right there. So not my best graph ever, but it'll work there. You will notice it did sort of reverse or flip vertically how this works here. So instead of going and increasing from left to right like the original graph is, we're actually decreasing from left to right here. All right, as far as domain goes, domain, that's x. X can be anything. We can plug in any number we want. So I'm going to write that as x is anywhere from negative infinity up to positive infinity. Range is y. How high does a graph go? How low does a graph go? Well, same thing. It can go as low as negative infinity, and it can go as high as positive infinity. So that would be our domain and range. So that's it. You've seen now how to use a, h, and k and with other kinds of functions. And honestly, it's a lot like the parabola function. Once you learn how to do it there, it just goes ahead and can be used elsewhere in other functions as well. I hope you enjoyed the video. Thanks for watching.